Today, Waymo is the only company in the world with a fleet of fully self-driving cars with no one in the driver's seat on public roads. So Phoenix will be the first stop for Waymo's driverless transportation service, which is launching later this year. Soon, everyone will be able to call Waymo using our app, and a fully self-driving car will pull up with no one in the driver's seat to whisk them away to their destination. Google is already deploying a new technique called deep learning, a type of machine learning that allows you to create neural networks with multiple layers to solve more complex problems. So, our self-driving engineers teamed up with researchers from the Google Brain team, and within a matter of months, we reduced the error rate for detecting pedestrians by 100x. That's right, not 100%, but 100 times.
Now at Waymo, AI touches every part of our system, from perception to prediction to decision-making to mapping and so much more. So first, perception. Detecting and classifying objects is a key part of driving. And pedestrians in particular pose a unique challenge because they come in all kinds of shapes, postures, and sizes. Here's a pedestrian crossing the street, concealed by a plank of wood. And here, we have pedestrians who are dressed in inflatable dinosaur costumes. Traditionally in computer vision, neural networks are used just on camera images and video. But our cars have a lot more than just cameras. We also have lasers to measure distance and shapes of objects, and radars to measure their speed. And by applying machine learning to this combination of sensor data, we can accurately detect pedestrians in all forms in real time. A second area where machine learning has been incredibly powerful for Waymo is predicting how people will behave on the road. Now, sometimes people do exactly what you expect them to, and sometimes they don't. Take this example of a car running a red light. Our car is about to proceed straight through an intersection. We have a clear green light, and cross traffic is stopped with a red light. But just as we enter the intersection, all the way in the right corner, we see a vehicle coming fast. Our models understand that this is unusual behavior for a vehicle that should be decelerating. We predict the car will run the red light. So we preemptively slow down, which you can see here with this red fence, and this gives the red light runner room to pass in front of us while it barely avoids hitting another vehicle. And with this kind of scale, both in training and validation of our models, we can quickly and efficiently teach our king of the world around them. Our vehicles need to understand and classify objects, interpret their movements, reason about intent, and predict what they will do in the future. Our fleet has self-driven more than 6 million miles on public roads. And at Waymo, we use the TensorFlow ecosystem and Google's data centers, including TPUs, to train our neural networks. And with TPUs, we can now train our nets up to 15 times more efficiently. And we can't wait to make our self-driving cars available to more people, moving us closer to a future where roads are safer, easier, and more accessible for everyone. Thanks, everyone.